motor starters and valves, effectively managing machines as required. Now that you know what a PLC is at a high level, let's look at the key components that make up a PLC system. Power supply provides necessary voltage for operation. CPU contains the processor and memory to execute the program. I/O modules interface to field devices like sensors, switches, valves, motors, etc. Communication modules allow PLCs to communicate data over industrial protocols. Programming device, a computer used to develop and load logic programs.
Okay, so this is a small introduction about a PLC. So the PLC will, whenever you're going to a industry, you can see that nearer to each and every machines, bigger machines. So you can find that a PLC panel in the next to that. Okay, so this is a low-cost automation. We can use PLC applications in the low-cost automation when you are doing. You can use for hydraulics and pneumatics applications, and then you can go for that. So this is the easiest way for doing thing. This a simple way is introduction to PLC when you are using for sorting operations.
This teaching set provides a complete introductory course in the programming and troubleshooting of industrial control applications. Working with an industrially relevant applications trainer, learners progress at speed through a series.
So you can see that the component is entering. Then
the teaching set also includes an Allen Bradley PLC controller,
the sorting action
manual, sequence switch module for manual activation of PLC inputs, components that are to be maneuvered through the application trainer according to their size, cables to interface the trainer with the PLC controller, a hand pump compressed air supply, and a ladder logic software editor. The applications trainer is a convenient desktop system that interfaces with the PLC controller. It contains electronic sensors and electro-pneumatic actuators that are used in real industrial applications. The curriculum manual.
So this how we can write a program, and then we can connect with the small pneumatic and hydraulic systems. So the robotic system, when you are moving to a robotic systems, we can develop different types of robotics. And you can use servo motors. Any of the electrical motors you can use for each and every joint, and then you can obtain the motion. Otherwise, you can go for hydraulic systems or pneumatic systems for your robotics arrangement of when you are developing your robot. We can use either pneumatic or hydraulic or any of the electrical drive. So this also one method. Simply you can use some pneumatic pressures. Or if a load is huge, then we can go for hydraulic and we can develop our own robotics. So for that, we need to know that each and every sensor action. So once a sensor is sensing, then we need to plan accordingly, then we need to actuate. So the mechatronic system, when you're talking about sensing, plan, and activate. So that's the same like whatever our body is doing. Whenever the mosquito is biting us, then immediately our skin will give a information, convey the information to our brain. The brain will give a action to the hand, then either to kill or to send away. Okay, so that's how we are developing a sensors and then controllers and then actuator. So this is how we developed in a PLC. So PLC and then CNCs, and then here I'm showing that how the PLCs look like in our lab. I took some of the video for basic understanding of how to use a sensor, how to connect a sensor to the PLC, and how to actuate a motor. Okay, very simple programming I made it here. So you can see that it's a bigger box. It's not a full PLC. When you open this, you can see that the white colored here, this is a PLC. Okay, so this PLC is available here. So here a lot of inputs are available here and outputs are available in the down. Okay, so number of inputs. So 12 inputs will be there, and divided by 2, 6 outputs will be there. So this is the extension part, and this is the main part, the PLC part. So you can see here 1 to 12 inputs are available here, and then the output side you can this is a PLC. The output side, if you are seeing that 1 to 6, it will be there. So output will be there. Okay. So this is how we are getting 12 inputs and then outputs. So we want extra additional output. If you want to 12 by 12, then we need to go for additional extension. It's made here, and it is showing here additional 6. Okay. So power supply, we are getting 230 volt power supply. So in the 230 volt power supply, we are getting here in the blue colored 230 volt power supply. Once if you are learning a PLC, that will be useful for controlling a robotics. So just so that I'm showing here. And then transformer and center tap transformer here 24 volt AC will get, and 24 volt AC will uptime. So this 24 volt AC we have to convert as DC. So for that we have here rectifier circuit. So here rectifiers are there. So it will convert to 24 volt AC to 24 volt DC. So once if you are uptime 24 volt DC, the 40 and 39 line, we can connect the power here to the supply. 24 volt supply we can provide it to the PLC. So once if you are given a supply, and additionally if you are have an extension, for extension also we need to provide a supply. So once if it is ready, then this is the overview of how the PLC is look like. So once this is over, and next video is showing that a small program. So one sensor is connected and one actuator is there. So once the program is made, then we need to go for online and transfer the device. That means that transfer whatever the program you have written, that will be transferred to a PLC. So once it's put it in the run mode, then through RS-232 cable, the program started entering to the PLC. Started enter to the PLC. Then the program is uploaded to the PLC right now. So how it entered, so you can see here RS-232 cable, the white color cable that will be connected. That is connected with the black color dot. So if you are pressing this, you can see here the program, whatever the program I uploaded here, that program is available here. Okay, so this is very simple. You can write a program. So once this is a way to write a program and uploading a program. I'm very simple, only one line I made it. So here I'm connected the I6 sensor here. Okay, the sensor. So whenever it founds here, then it will sense. You can see that the motor is running. Whenever the sensor senses, the motor will run. So this is a very simple, easiest way we can connect the sensor and the actuator for our work. So that's a simple method of connecting a sensor with the actuator with using of a PLC. Okay, so this simple interfacing you can do once if you have learned, then we can do it for the industry very easily. So and the simple application based upon whatever the idea we obtained, the PLC and sensor idea what we are obtained. From that we can go for a small robotic system by using of pneumatic and pneumatic systems, either pneumatic or hydraulic. Here I am showing here a pneumatic system. Okay, so the pneumatic system you can see here. So everything is automated. So everything is automated by using of pneumatics. The pneumatic system, it's everywhere it is automated. It's very simply we can move the component one place to another place. It's very simple way. Okay, so you can see that a small movement you can take it out, picking and placing operations. This is how we are started developing of whatever the knowledge we have in the sensors, actuators and PLC. We can start developing your own robotics systems by purchasing of pneumatic actuators and FRL unit, whatever the things you want, you can purchase and you can start developing your own robotic system. So everywhere we are using a pneumatic lines, picking and placing, everything it is taking care. Okay, picking and placing exact locations. So this is how we need to start developing our own robots for our personal uses in lab uses. This is how we are started the robotic system. Then it keeps going in. So nowadays we started getting high-speed robot application also in the same pneumatics. In the pneumatic, if you are having high-speed applications, so very fast you can run. So you can see that the ball is there. The ball is there here. The cup is rotating is very fast, and then it is getting back again. So you can see that how fast it is moving up and down. So not only for very slow movements, you can obtain the fast movement also, high speed movement also by using of this pneumatic systems. So you can develop your own robots by using of Festo or different genetics, Festo, many things are there. And now the third one, the Industry 3.0 technologies. First we discussed the PLCs, and second first we discussed the CNC machine, and second we discussed the PLCs, and now we are entering to the robotics. So the robotic system, this is our core area where today we are looking for. The robotic system, when you are moving to the robotic system, whatever you see in the yellow color, normally if anyone is asked that, normally we will say that this yellow color is the robot. It's not a robot, it's a mechanical unit. So this mechanical unit will be there. So when it's called as a robot, when you are adding with the controller, robotic controller. So this next to left side of your screen, you can see that the robotic controller, that will be programmed by using of teach pendant. So this is this facility is there in our lab. So this is M6ID robot with RJ3 IC controller. So this facility we are having here, and we are giving a training to the students. So when you are seeing here this robotic system, so I want to go for why we need to replace the human for the robots. Why we need to bring the robots instead of human being. So some places where we can find much hazard place will be there. So those places human being can't involved. So those places we can use this robots. So normally I'm talking about robot, but not in the industrial robot. Normally I'm talking about normal robot. And sometimes if you want to do a repetitive task, so people will get bored up. So they don't want to do a same job 24 each and every day morning coming to the office and doing the same work. So they don't want. So the unpleasant task, and then multi-shift operations, and then performing a study work if you want to do. And if you want to continue long hours without rest, we can use. And minimizing the waste. That means that the quality we can increase. So those purpose we can go for robotics. And if you are seeing that robotic applications in industry, if you are seeing that material handling applications are there, and material transfer one place to another place, and then picking operation, placing operation, palletizing operation, and then machine loading and unloading operations. So a lot of operations are there. And assembly inspections. So we can do an inspection by using of a robot. The robot can be used for inspection application also. And then the processing application operations, if you are seeing that painting work and welding, and then cutting, grinding. So all those work we are using here. And then the picture, whatever the picture it is shown here, if you are seeing the top 10 countries by robot density is more, you can see that the Japan is they are more. They are having more robots. And then next to Singapore, like that, it's keep going the number of users. So the industry or the robot is a next generation is robot. So when in 2010, many of our students in 1996 to 2000, many of them, if you are seeing that, if they're everything they are getting automation. So they want to go for automation. They want to go for robots so that the robot field is keep growing. So many of the industries available in India, if you are seeing that they are developing, they are designing and developing the robots here, and they are selling to the foreign countries. And in future, and students who are studying here now in the robotics applications, so they'll get the robotics will get boom soon, and they'll get very good jobs like whatever the IT field is developed 2 decades back. So pick and place operations, if you are seeing that where we are using robots, so pick and place operations, picking component and placing. So this is the pick and place. So you can see that how it is picking and how it is placing. So this is a pick and place operation. And next one is loading and unloading operations. So you could see that unloading, this is unloading the component. And then once you can see that same time, it's a bigger pallet is there, in that it is taking out a required component, and then it is keeping here for the next operation. Then the robot, now the robot 2, after completion of the work, this will come back and take the component and then ready for loading, machine loading. So machine loading and unloading, the robotics are taking care in Industry 3.0. This programming also we can easily write. And then welding application, if you are seeing that the gang robots doing welding, first it is making a spot. Each and every places it is keeping a spot. It's a gang robot. So not only for one robot, we can go for multiple robots, and then we can do tasks simultaneously to reduce the time consuming. It is making a spot weld now. So once this is how we can get welding applications. And then nowadays in industry, they have started using the air muzzles. So for robots, they are started using the air muzzles. The air muzzle is an extraordinary actuator that is very small and light and very friendly and soft. So we can use these air muzzles for developing our own robots, recent robots. So these air muzzles, I hope many of you are not aware of this. So this is a newer application recently developed, and even this we can make on our own. Okay, so this air muzzles, if you are seeing that, how it just overview I'm showing here how air muzzles. When you are taking a load, you can see here in this portion. So this is, we are getting a movements like this. So that movement we are getting air muzzles. Sending air and taking out the air. You can see that the load taking, it is taking load, expanding and retracting. So this is how we can get the air muzzles to take a load. So some of the sizes it is available, so we can use whatever the size we want. And the robotic application, if you are seeing that how the robotics, so when
in the case of the humanoid, the test was to transfer the biomechanics of the human musculoskeletal system to a technical construction.
You can see that the black color are the air muscles.
Is Festo's fluidic muscle. Already a permanent feature in production systems, the fluidic muscle is proving to be a universal tool in a surprising number of new applications. It's simply a completely new type of pneumatic drive. Its properties are similar to those of a real muscle, but it's operated with air. When the fluidic muscle is filled with air, its diameter increases and the length contracts. This enables flowing and elastic motions. The initial force of this artificial muscle is extremely high, and its dynamics resemble those of the human muscle. The humanoid can either follow pre-programmed motions or be controlled in real time via a data suit and data gloves. This means it can be used in places which are either inaccessible or too dangerous for humans.
And then now, whatever the robots we have discussed, now we are going to add the machine vision system to the robot. So this is a third industry 3.0. We added the camera to the robot. So why we are adding a camera to the robot? So it's look like if we are closing our eyes and if you're someone is giving an instruction that move your hand to 10 mm right side and down 10 mm down and try to hold the component. So if they are giving instructions, we can't hold the component properly. So but if you open our eyes, if you are seeing that the component, what orientation the component it is available, what shape, what is the orientation, so how it look like, so that we can the component, so I'm seeing that whether it is a glass material or whether it is a heavy material, so depends upon that how much force I need to provide. So these are all the things I can get once if I'm introducing a camera vision system to the robot, so that we started introducing a vision system to the robot to identifying some assembly. A lot of components will be there. If you want to take it out a particular component, so that from the whole bin, we can take it out the component by using of the camera. So that's how we are using this. So vision system, if you are seeing that the vision system for the robotics, so you can see here the overall. Here the camera is embedded into the gripper itself, so that here you can see that the image library here. So whenever it operates, it will take an image. Whenever it moves, it will take an image and it will find that whether it is perfect, then it will allow. If it is any defect is there, then a small ejector is kept. The ejector will eject the component. So this is how we can start using of these robotic systems. And how to connect the camera with the robot controller. You can see that the robot controller, I already said that robot controller is separately RJ3 IC controller is available. So in the RJ3 IC controllers, if you have opened the panel, you could see here inside the panel like this. So just you need to, the camera, just you need to insert the camera so that it will start connecting with your robotic system. So this is how it's very easily we can control. So either you can use Ethernet or personal laptop you can connect. And then once if you don't have a laptop or if you don't have a PC, then you can start seeing the camera visualization in the teach button directly. So directly you can see in the teach button and you can use. So once if you are writing a program, then you can easily you can run. So first we need to provide the data to the robotic system. So robotic system has to understand what is a component. So for that we need to give an input. So this video it is showing that first I'm keeping one component, and the component I'm fixing the component. This dimension is fixed, and then given a center point. So it is taken a center point, and then this is a component. So it is now it is the controllers understand what is a component I'm expecting for. So if I want to move the component, so you can see that it is showing a rectangular as it is. If I'm rotating the component, so if I'm rotating a component, now we can see that the rectangle, whatever the square it is there, that is getting angular, so that based upon that your arm will come and take it out from that particular orientation. So that's a component identification. So simply we can identify the component, and you can see that some of the examples, the vision system implemented robotics, you can see that the biscuits are once it is cooked, baked, and it is coming out, and you can see that how fast the robot is taking out. Here you can see that the lighting and camera here, and camera is keep watching, and it is once if it is camera is taken an image, so you can see that here what orientation it is entering, what is the size and everything, orientation, everything it is giving. So based upon that, each and every joint, that means that the servo motors get the feedback from the controller. So accordingly it will move and it will take out the biscuits and it will keep it exactly. Precisely it will keep. So this randall we are getting in robotics in industry 3.0 we are getting now. So here you could see here these glass fixing operations. So first whatever the program it is made, that program the manually it is mentioned. So manually it is trying to keep. So sensors are available. It is manually it is keeping. It is found that some problem is there. It will come back again. And now it will go back and it will take its own measurements by using of IR lights and camera. It will take own measurements. So this adjustment, the round they made manually. So now it is going and measuring. So once if it is measured, it is identified that where is the exact location. So once if it is found at the location, it will come back again. You can see that the error. So whatever the circle is made and whatever the gap it is hold. So that's the error it is found and now it is fixed exactly to that. So that means that it auto correct whatever the error is there, it will auto correct and it will keep it. Okay. So this is a robotic and the sorting applications. So two types of components are there. So one is bigger and one is smaller. Oh, sorry, it's videos. I forgot to connect the video. So two types of component sizes of boxes are there. So once the camera is sensed, then automatically it will keep it here and here based upon the component sorting. Okay. So this is a deburring. So once the component is find out the debur, then it will start doing a deburring operation. So here debur is available, so it will start do. So now what we are did is machine systems we are started implementing in conveyors. So the sorting applications.
Housing integrates everything required for an inspection task. Camera with lens, illumination, hardware and software for image processing, and of course interfaces. After a one-time configuration in 4 intuitive steps on a PC, VeriSense is ready for results. Up to 20.
So once if you are written a program, then you can be
object inspection.
Free, then it will start working.
The results can be compared against the targets in any industry and across a wide application range. Molded parts.
So once the manufacturing is over, the camera will capture the image and the actuators. So the robotic actuator or whatever the actuators, it will start ejecting the component. So it is finding out the component whether it is a defect, then it will eject. It will eject. This is a pneumatic system we can use. So once if it is found that it is a problem, then it will reject.
Easy color inspection.
Like that color inspection we can do.
Often turns
sorting.
out to be a challenge. Is every color in the right place?
The automotive industry is fuses. So fuses we can easily find out.
What the human eye perceives as brightness, hue and saturation is mapped by the VeriSense Color Effects Assistant in an interactive 3D color model for easy and intuitive color inspection.
This is how we can do
packaging and
here. So up till now we discussed about industry 3.0. Industry 1.0 we discussed, industry 2.0 we have discussed, and now industry 3.0 discussed, then we are moving to industry 4.0. When you are moving to industry 4.0, the industry expectation now it's keep increasing. So you can see that the picture, it's showing a lot of requirements, intelligent and integrated process, manufacturing, cloud computing, and then advanced simulation. And you can see that the data, big data, sustainable, we are talking about a lot of things, and sensor-based networks, a lot of things we are talking about. And also nowadays we have sustainable goals. So we need to go for a zero emission. We need to obtain a perfect system. So the industry expectation is industry expectation is there. So in that we need to match so that we are moving towards industry 4.0. So when where we are right now, when you are seeing that industry 3.0 we are working, and now we are moving to industry 4.0 where the cyber physical systems are available. So the cyber physical systems, physical systems will be there that will be controlled by the sensor data. Based upon the sensor data, we can have a separate digital system that will control the physical system. That is cyber physical systems we are using. You can see that digital twins, we are talking about digital twins. Whatever the motor is there, that motor will be digitally we kept next to that. So we are moving towards industry 3.0 to industry 4.0, the next level. So in current scenario, if you are seeing that, you can see here the source, whatever the raw material we are obtaining from Africa, example. And once if it is obtained, it will move to China, and they are doing a manufacturing. Say example, China and India, we have very labor, very easily you will get a labor, so that once the source is taken out, then directly they will send it to China or India, where more labor or less cost labors are available. So that places they'll have a manufacturing unit and they'll do manufacturing. And once the manufacturing is over, they'll send, as per the diagram, it shows that it's sent to Europe for the testing. And then the customer will be there. You can see that Russia and South America and other places. But headquarters and R&Ds will be there in America. So this is how the component somewhere, the component is getting from some point, and manufacturing in another point, testing in another point, and then headquarters is there in a different country, and then R&D facility will be in the different countries, but everything is keep going. So if headquarters, they want to know that what is going on in the particular company. So example, if it is there, a company is located in China, and in China, that company, how many plants are there in a particular plant, so particular cell, particular machine. So each and every machine, they can understand that what's going on. Okay, this is how they are doing and finding out, and they are easily they are connecting everything. So if you want to connect, so we need to have internet. So internet of thing, we are talking about internet of things and other things. So we need an internet to connect. So each and every machine will be connected to the internet. Once it is connected to the internet, wherever you are, wherever the country you are, wherever you are, you can start locating by using of a tag. You can easily check, and then you can take it out the status. So this is how we are going. So for starting out this, we are moving towards industry 4.0. So when you are going to industry 4.0, we need to know that why we are going from here, the automation to smart manufacturing, and we are integrating IoT, AI, big data, and cyber physical systems and other things. So you know that Internet of Things is keep developing nowadays. And industry 4.0, when you're talking about industry 4.0, this is a new phase of industrial revolution to introduce intelligent networking. So if you're seeing here, so whatever it's showing here, the machine to machine. So inside the machine to machine, it will connect each other. Okay, so normally continuous machines are there, around 10 machines are there. And if any one machine is getting repaired, then immediately the worker knows that this particular machine is repaired, then you need to plan accordingly for the next machine. So now in this case, industry 4.0, once one machine is getting repaired, and that machine, no need to expect the people to come, and immediately it will connect to the next machine through Wi-Fi, directly connect to the next machine, saying that I am out of work, so that you will get the component, whatever the component you want to make it, you can route it to the another machine. So like this, it will convey with each other, so that we can move. Same like that, the factory to factory. if they want to discuss, so factory, then they can discuss using of this Wi-Fi. And then wherever you are, we can take out the signals. That's mean that the data we can take it out, fetch out, and you can see that what's going on, the transportation, where it is exactly located, the component where it is located, manufacturing and machines, everything we can check it out. Okay, so this is how we are using this Wi-Fi module and no wires. So now the sensor, whatever the sensors are there, each and every one machine, we have around number of sensors. Okay, all the sensors, all the actuators will be named. That's mean that they'll tagged. Okay, so once it is tagged, then we can see that which sensor, example T01, one sensor and naming it as T01. So I can see that wherever, even if I'm there in a foreign country, I can go into a cloud system, and then I can see that particular sensor's data. So what's going on? I can see that. So it is very easy for getting a data if it is Wi-Fi. Otherwise, previously in Industry 3.0, what they used to do is, if they want to do a condition monitoring, so if particular machine's condition monitoring, separate the sensors will be there in the machine. That machine's sensors will be connected to the nearer to the some of the computer nearer to that. That computer only it will store. So if anybody wants to know about the condition monitoring, they need to go nearer to the machine and nearer to the computer. They need to open the computer and they need to see that what's going on. But now, once if you are using the Ethernet and if you have started emitting, so wherever you are there, you can log in and then you can use. This is how we are going. So Industry 4.0, just for understanding, one small video.
A vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized, and resource-friendly mass production. That is the vision for the fourth industrial revolution. A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively. Siemens is shaping the future of industry. Connecting the real with the virtual world of production is making it possible to enter entirely new dimensions in quality, efficiency, and flexibility. The company is well prepared for Industry 4.0.
So this is how we are, this is a idea of what is the Industry 4.0. So this is the next 9 pillars of Industry 4.0 where we need to have we are all doing research simultaneously. We want to know that what are the important area in Industry 4.0 where I can start do my research. So this video will give you an overview of idea. So what are the important areas where we can work for Industry 4.0. So virtual reality. Second one is additive manufacturing. So additive manufacturing, layer by layer manufacturing. So lithography method. So normally we'll do a machining like this. We'll remove the chip, additional chips. Okay, so this is a way of subtractive manufacturing we did. So to overcome this, now 3D printed machines are came. This is a SLS method where a selective laser sintering, we can deposit layer by layer, you can develop and you can obtain your own product very easily. Even a complex product, we can get it. So layer by layer, you can manufacture even IC engine also. Third one is Internet of Things. That already we discussed, Internet of Things. Next one is a big data. Fifth one is a cloud computing, where we have a space. Advanced simulation. So previously we used to separately we made one car for doing some crash test. Nowadays everything we can do it in simulation. Simulation we can try so that the huge cost is reduced. Autonomous robot where we are studying right now. See, the cyber security is much important because we are using an internet. So one place to another place, we are transmitting the data. So when you are transmitting data, someone should not enter in it, and they should not take it out the data. So we need to have a cyber security also. So these are all the 9 pillars of the industry 4.0. And then, so what are the key technologies what we discussed? It is shown here. What are the key technologies? IoT, AR, VR, and additive manufacturing, cyber security, cloud computing, big data, and everything is shown here. And if you are seeing that advanced robotics, we are moving towards advanced robotics in 4.0. So previously we saw that the robotic system. So when you are seeing that the robots, so normally the Fanuc robot or ABB robot, or whatever the robots, they'll make a fencing. Okay, so they'll make a fencing. So that's mean that no one should go inside when it is work, the work volume, no one should not enter. So when some people are entering, so when it is moving, it will hit the people and it will be harmful. So that they'll make fences for that. And now we are removing the fences by making the robot getting intelligent. That means that slowly we are removing all those fencing problems, and then now we are moving to that. And now robotics are programmable machines that usually carries the autonomous work and non-autonomous work. And now the safety side. So human can work along with them. That's a collaborative robots. We have started developing a collaborative robots to work with the humans. Okay, that's how we are moving now. And industrial Internet of Things, you know that nowadays we are wearing smart watches, and we have in our home, we have a camera. When we are going out, what we are doing, we want to know that what's going on in our house. Immediately we will take it out our mobile and we'll just open the video of the footage, live footage, and we'll see that what's going on. This is a example for IoT. The example, when you are wearing your watches, smart watches, and your blood pressure is increasing, then it will give you a small alarm, and it will ask that do you want to connect with the local hospital. Then if you want to put yes, then it will automatically call the local hospital, and it will inform about your health. So that's mean that everything, once if you are giving okay, then it will start connecting with internet. By using of internet, it is connecting another devices, and then it start working. That is called as Internet of Thing. So it's not only for that in home automations, like I already said, that the camera connection and whatever it is. Nowadays, everything we are using mobile. So whatever we did, without our minute, we can't be with our mobile, because in the mobile we are connecting everything. So even the data, whatever the data we want, everything we are connecting. So that's Internet of Things we are moving. And next one is artificial intelligence. So the robotics need artificial intelligence. So the robotics is a separate field, and artificial intelligence is a separate field. So these two fields, if you are bringing together, if you are seeing that the circle I'm shown here and the robotic here, and another one is artificial intelligence, if you are bringing together and wherever they intersects, then we'll get an intelligent robot. So intelligent robot in the sense, the robot will learn and it will plan and it will understand and it will solve the problem then and there. That means that once if you are going, you can go for machine learning also. Machine learning, that's artificial intelligence. Part of that machine learning also it is available. So in the machine learning neural network some part. So in that what we can do is we have to create a huge data, that's a knowledge base. We need to create a knowledge base. So for that each and every signals, sensor signals we need to obtain, and we need to have a knowledge. And based upon the data, whatever the data we are, sensor data we are obtained, based upon that we need to train the machine. Once we have trained the machine, then we can build a model. Then we can start predict what's going on. Say example, when the tool is about to get break, then immediately the sensor will sense that how long the tool we can use. So once If it is very nearer, then immediately it will automatically, the tool magazine, it will change it out. Okay, that means that we can use the tool optimally, and we can identify that what's going on wrong. So these are all the things we can develop through machine learning. So the machine learning, if you are giving, then the robot will get intelligent, and whenever the decision is required, automatically it will take a decision. So then it will move further. So cloud computing, if you are seeing that the cloud computing, you can, the cloud computing is much important nowadays. How we are doing the Gmail account. So if you want to use a Gmail account, I don't have a mobile with me, I don't have anything, I'm going next country, another country, I lost my laptop, I lost my mobile, I lost my tablet, whatever it is. So if you are going somewhere, and if you are finding some laptop or something, you can type your username and password in the Google, then you can retrieve your things. So nowadays we are doing everything by using of mobile. So we are paying. So after COVID, it helps us a lot. So everything is digital. So digital meeting. This meeting also happened because of the digital advancements, whatever the digital advancements we are obtained. And digital advancements like online shopping, we are doing online shopping, whatever we want, we can go, we can purchase, then automatically they are giving back. Online shopping we are doing, online teaching we are doing, and then video conferencing we are doing, and then digital money we are sharing. So everything is cloud computing. So cloud computing we are using, and we can, wherever we want, we can take it out. So nowadays Amazon and many of the companies, they are having their own cloud where you can store your data. So we can fetch by using of the username and password. So this also can be useful for the robotic system, the industrial robot system. We can store the data in the cloud, and whenever it's required, we can pull out those data easily, and we can run. And the cloud nowadays, we are using a cloud for storage purpose, and we can store the data in it, and then we can browse your tablet or laptop or desktop, whatever it is, mobile phone, you can take it out. And nowadays the maintenance, that's a predictive maintenance we are doing. Each and every values will be stored there, and then you set up algorithm if you are writing either the machine learning algorithm or artificial algorithm, or sometimes deep learning algorithm if you are writing in a cloud. And based upon the algorithm, it will find out the sensor data. Based upon that, it will give you the output. So what you have to do, what all the action you have to do. So that the cloud work will get. So augmented reality, we discussed that virtual reality and augmented reality. Virtual reality, the augmented reality here, then example, the digital information will be there. So that we are going to superimpose with a natural environment. So example, when you, in some of the movies, you would have seen that when the person, the thief, when seeing the people and the gold ornaments, so the amount will be tagged like that. Here also, wherever you want, what all the operations you have to do the next. So those things will be displayed like in this picture. You would have seen that he is wearing a goggle, and seeing that how it look like. Okay, so this is a way you can do. Even we can do it in our mobile. We can do our own, the softwares are free, softwares are available, augmented reality softwares are available. You can use augmented reality software. You can write your own program and you can get it. So this is how we can do it in reality. And big data analysis, when you are seeing that the big data analysis, lot of data. So wherever we are talking about the data we are obtaining, say example, when you are trying to book a train ticket to Chennai to Bengaluru. So once if you are trying to book and tickets are full, and immediately you will get a message, the blah blah car is there, you will get it for 2,500 rupees if you are, or you want to use. That's mean that they have a big data. So once something goes wrong, then immediately they are triggering the values. Say example, in Amazon or Flipkart, if you are trying to purchase one pen drive, and if you are searching for a pen drive, next 1 week you will whenever you browse, everywhere you can see the pen drive advertisement. So that's how they are fetching our data, because when you are using a Google, we are giving our data to them, To create a Gmail, we are giving our age, our name, age, gender, everything we are giving to them. The data is available with them, and by using that only we are entering to the Chrome. And once you are entering the Chrome, and if you start searching, so when advertisements and all, they are seeing that whether the person is aged person, then it will show that it will understand that this is an aged person, so automatically it will show that sugar tablet advertisement and related stuffs it will show. If it is a guy who is 20 years old, then Adidas shoe model, and like that it will display. Okay, it is a gal, then it will show that cosmetics advertisements. So like that, it depends upon the age, because everyone don't want all the advertisements. So we are specifically we are giving. So big data, it's helping like this. So just for example, I'm talking about, and like that we can create the whole industry data we can obtain, and we can create a big data. That big data will be useful for extracting useful information from out of that. So that purpose we are using this thing. And cyber security, already I mentioned that if you are using internet for connectivity, nowadays we are moving to industry 4.0. We are started using of the internet. So through that, people are more smart, and especially in India, people are more smart. They can hack. So hacker will be there. So once they are hacking your program, and they'll start their own small industry. And example, the Reynolds company, previously the Reynolds pen will be there. The Reynolds pen, it will be cost around 5 rupees, and 50 paise I'm telling about my childhood time. 50 paise they made one small pen. That's the quality won't be there, but the same shape, same size, same color, everything will be there. So that's mean that once if you are obtained the data, you can start produce on your own with less quality material. So that and all will happen, and finally the product name, brand name will go off. So that to avoid that, we need to have a cyber security. In not even for other things, robotics also we need a cyber security systems. And component of a robotic field, if you are seeing that whatever the field we have discussed, Internet of Things, cloud, big data, and many things we have discussed, artificial intelligence, everything it is shown here. And then industry 4.0, how the machine vision is helping.
What will the manufacturing of tomorrow look like? Industrial parts are becoming smaller. Products get to market with less waste, faster, and on time. Even the most manual processes are turning towards automation. Innovations in machine vision, deep learning, and robotics are revolutionizing production lines and supply chains. Our machines now produce vast amounts of big data accessible via the cloud. As machines and the information they produce become linked, new cyber-physical systems will spark a modern-day industrial revolution. This is Industry 4.0.
So benefits of Industry 4.0, you could see that we will get a productivity and efficiency will increase, cost optimization we can get, new opportunities we will get, customer satisfaction will be more, and moreover, mainly the safety is increasing. Okay, so these are all the things. And now we are talking about Industry 4.0. Now when we are talking, the people are already started moving to Industry 5.0. So Industry 5.0 already started, and some places they have started working. And next is Industry 5.0. We are not at reached that level. So you can see that human-robot collaboration and cognitive systems. So this is how they have started developing Industry 4.0 to 5.0. They have started meanwhile. So you can see that 5.0 is emerging, and it's going to come, and we are going to work in Industry 5.0 soon. And then Industry 5.0, about overview, Industry 5.0, I'm small clip I'm showing. So cobots is a main important collaborative robots. They have started developing a collaborative robots to work with the human. So this is the newer thing will be on 5.0. Okay. So these are all the research field where we can work in Industry 5.0. These are the key features. So human-centric manufacturing, AI-human collaboration, sustainability, green manufacturing, adaptability. These are all the areas where we can start work now. And once you are working, and we can get some papers in the future. Okay, so I have some of the videos to understand, but time is not permitted. So I want to show some few clips and I'll move. So this is how we started getting bionic cobot. So which will work along with the human cobot. See, it will work along with the human. So this will work. So it will help the human when he is working. It's look like a person sitting next to you, and it's helping taking a component and giving you back. So this is how it will be there. So this is a co-worker like. Okay, the co-worker is sitting next to us, and it will help. So this is a artificial neural network how we are implementing in the robotic system. So you can see that once the robotic system is made and bionic soft hand, so in that the artificial system to learn how to move the component. So you can see that tactile sensors will be used. So camera will be used for showing. I don't have a time to move this. I'll move. And key features. So we are sustainability. That's the main thing. So here Industry 3.0 never bother about sustainability. And then emerging concern, we started thinking of sustainability in 4.0. Now core principle of Industry 5.0 is a sustainability. That's the important one. Okay. So you can see that how it is increasing. People 1970s and 80s, more people are working. And after that 90s and 2000, we replaced the human, and robotics we included. Now in 2020, we are moving to fifth revolution. You can see that the robots will work with the human. That's mean that high flexibility and high productivity you will get. So that's mean that now collaborative robots are started developed, and it will work with the human being. So this is how we are moving in 5.0. And please get ready for to face the Industry 5.0, and 4.0 is already over, and people are started entering to 5.0, and be ready with that. And thank you now. With this, I want to thank the organizers. Is it audible?
Yes, sir.
Yeah.
Thank you, sir. Thank you for your valuable speech.
Yeah, thank you. Thank you for the management team of JCT College, and then principal of JCT, and then HOD G.Mahesh, professor and HOD, and the coordinator, and co-coordinator Mr.M.Prabhu. Thank you, Prabhu. And thanks all the participants for your patient listening, patience listening for this particular session. And I thank the ATAL team also. Thank you.
Thank you, sir. Very nice, sir.
Any questions?
So participants have any question?
So 1 or 2 questions we'll close because it's around 7:30. Sorry, I'm
Hello.
much time of yours.
I'm audible, sir.
Yeah, I'm audible. Yeah, audible.
Sir, you please. I have the query. So, what is the meaning of cloud computing, sir?
The cloud computing. See, I already said example. When you are storing a data. So, if you want to store a data, if a bigger company is there, the company, each and every machine has number of sensors. So number of sensors will give a data. So that means that 24/7, the data will keep coming out. That data I need to store. So normally in industry 3.0, they will keep a computer nearer to that, and that will be connected to the computer, and it will keep storing in a computer. So now we are started moving that data through wireless. We have started sending to the cloud, where we can purchase a huge space, a common space we can purchase, and we can send the data to a cloud, and we can use username and password, and we can fetch the data. So whenever we required some work, so we can fetch the data and we can do. Sometimes we can write some algorithm in a cloud itself, and like a condition monitoring. So if anything goes wrong, then the cloud will get a signal.
So that means it is a virtual place. It is not the actual servers type system, no sir?
Yeah, it's not an actual type system. Separately, people will, Amazon is maintaining in Singapore. One is a bigger one. So many places they have places. So that's mean that when you are using iOS app, that's an Apple phone. So all the data, it will be stored in the iOS. So even though if your mobile is lost, when you are purchasing in a newer Apple mobile, and if you are typing your username and password, whatever it is there in the cloud, that will come back again to your system. That's mean that mobile. So that's how it works. So that's a cloud. Cloud in the sense we are keeping our data in separate area where it's not in a computer.
Okay, thank you, sir.
Okay, sir. Welcome. So I hope time is up.
Thank you, sir.
Thank you all. Thank you, Prabhu. Thank you all. So shall I
Thank you so much, sir.
move out?
Yeah, sir. Okay.
Yeah, thank you. Thanks a lot. Thank you all for your time.
So on this momentous occasion, I would like to invite our today's second session resource person, Mr.S.Karthik, Senior Consultant, APM, Capgemini, Bangalore. He has vast experience in the field of digital supply chain. Despite being his busy schedule, he has given consider for our FDP. I welcome you, sir. I will hand over the session to our resource person, Karthik, sir.
Okay. Thanks, Prabhu. Okay. Hi, Murubalaji. How are you? Okay. Murubalaji said okay. Okay, I think they are on mute. Okay. Hi to all. It's wonderful to have and to meet you all, and thanks for having me. I think the previous question about cloud, right? It was answered by Dr.T.C. Kanish, right? Adding one point to that question, to that answer. See, the main objective of cloud is to enable the availability of all our applications, web servers, app servers, database servers. The main objective is to ensure that whenever you use your mobile phones or any applications in your laptop, or any websites like say university websites or knock, whenever you do that, we have to ensure that there is a continuous availability of those applications or servers. So that's the main objective. The second is that if you are maintaining on-premise servers, let's say if there is a huge server located in an city, and if you are accessing that alone, if suppose happens to any one of that prod, we call it as a prod servers and non-prod servers. The production server where we get our applications and our websites into online, that is live. So those are live sessions where all these things happens. And there are non-production servers where we do all the testing. Of course, you must have heard about those things. So in parallel to production servers, we also have something concept called as CDR servers, that is continuous disaster recovery servers. So whenever, let's say, for example, HDFC Bank has different apps for handling. If you are going to access, but let's say if you want to check your balance, the HDFC app will not have one single server for all these things. It will have multiple apps with multiples, each apps having multiple servers. Let's say if you want to check your balance, it might have some application which will show your balances, and it might have some other applications when you want to transfer your amount, or whenever you click on the loan divisions, card divisions, this will be handled by different apps, and each apps will be having multiple servers. So when these servers gets affected, when it goes down, what will happen? Suppose if you are sending money to someone, and if your money is not transferred within particular time, obviously you will be frustrated, and that will bring loss to the HDFC bank. That will yield to the loss of business for the bank. So obviously what you will do, you will start hating HDFC. So HDFC will start losing the customer. So this cloud concept comes with the main objective that at any cost, none of the servers should go down. There are various monitoring happens. There are various monitoring tools like Datadog, AWS, that is Amazon Web Services itself has its own monitoring service like CloudWatch. There are Grafana and Prometheus, Splunk. These are the kind of tools which currently industry uses. And adding to that, there is a tool called Dynatrace, which I've been working the past 5 years. So that is an AI-driven tool, okay, that monitors most of these servers or applications to ensure that continuous availability of this server happens, and this Dynatrace itself is onboarded in AWS. So if you going down the history of this cloud computing, it was initially started by Alibaba in China, and that was parallelly it was picked up by AWS AWS Amazon Jeff Bezos. And then to compete that, currently, like 4 or 5 years ago, exactly during the COVID, Microsoft and Google were losing in the market. So they come up with, they came to compete with AWS, that is Amazon, and they built their own cloud. So currently Microsoft has the Azure technology, and Google has the GCP, that is Google Cloud platform. Yes.
Sir, I think your screen is not visible to us, sir.
Okay, it's not visible?
Yes, sir.
Oh, okay, let me share.
Okay.
Okay, is it visible? No, I haven't shared any data. I'm just answering to the previous question.
Okay, okay, sir.
Only I think my camera is on.
Yes, sir. I heard you, sir. I think you answered my question, sir. Thank you, sir.
Okay, okay. I understand. Okay, okay. That's about cloud computing. Okay. Let me share my screen. Okay. Hope my screen is visible to all.
Yes, sir, visible.
Okay. Yeah. Before, this is a very old concept, like, what is my supply chain management? Most of, I think everybody here knows about supply chain management. So, before getting into this session, I just want to have a couple of questions asked to our fellow people. Can anyone tell what is the latest trend in supply chain management? So, or you can use your our institutions as a supply chain management and explain how these things happens. Can you apply supply chain management into our college? Anyone? Good evening.
Sir, still not, sir. We are not using the supply chain, sir, in our college.
No, I just want you to apply that supply chain concept. You know what is the supply chain concept? Like, of course, just wanted to make you as an interesting of this session. I just wanted to imagine institution as an industry, your college as an industry. Imagine your students as a product, which emotionally you should not tell that, but in order to become successful, you should imagine your students as a product and try to sell them into the market. Because whenever you own an institution or any firm, the main objective or main purpose is to improve your business value. In order to improve your business value, you have to tell the world or show the world that your product is much greater than others. So in that way, you should imagine or you should start treating that your students, not as a product, but product means in the sense that they have the better edge compared to other colleges. Obviously, you won't, it is not possible for us to compete with the institutions that is existing for 50 years or 70 years, or institutions with better financial. So that is, yeah, that's one thing that can be agreed. But still, if you consider that your students as a product, and if you look yourself or try to imagine your college into supply chain, then you might start having some better answers. Can anyone try? We'll have a discussion. I know, see, there are many FDPs, many PPTs you might have gone through. I know I too have gone through. There are plenty of things, sessions you have attended. All these sessions, people will come, will give daily, will read out the things that are, written in the PPTs, and like blah blah blah. So this is what as usually happens. So I just wanted to a different way. So can anyone apply the SEM concept into your college? Let's try. Let's have a discussion. Then we'll get into the PPT. Imagine you have a class A, have 60 members. Okay, imagine you have 60 products in manufacturing sector A. So consider how you how we are going to maintain that supply chain. So what is the main core business value of supply chain in terms of colleges? How will you how will you win that or how will you ensure that your product has achieved SEM successfully? Anyone? Okay, just I think it's on February 14th, that too on Friday night. Okay, I'm sorry to keep you all ask questions. Okay, just wanted to have a, okay, I will tell something. Let's have a discussion. You agree or disagree, you let me know. So you have the alumni, right? Every college has alumni. So alumni, through alumni, when we work in the industry, I used to see whenever a fresher comes into the college, okay, whenever the fresher comes into the college, we used to see that people who are working from reputed colleges, when the junior or the fresher goes to is employed into the particular, or we put on board into particular project, when they see their seniors, or when they see a particular team leads or senior consultants or project managers from the same colleges, okay, they get bonded very well. So that's that's a power or that's a core value a college brings into. So this supply chain, you can apply that by imagining, okay, by ensuring that your students gets into large variety of sectors, and as you grow, years passes and you grow and ensure that those people comes back to you once in a while to the institution, but it's not practically it is impossible to bring the alumni back to the colleges. But at least sending the mails, or if there is any openings in the, any vacancies, or you can constant touch with them could help you. So that's one thing I wanted to put you. Okay, okay, I will begin my session. So welcome you all to the supply chain management. So as we told, there are many organizations, not many organizations. Every organizations want to, let me switch off my camera, some reflections. Is it okay to switch off the camera or you need kept open? Prabhu?
Yes, sir.
Okay, it's fine, right?
Fine.
Okay, okay. Thank you. Okay. So what is supply chain management? Any industry or any sector, it doesn't matter. It doesn't have to be industry. It can be a bank. It can be a telecom giant. It can be a retailer. It can be a manufacturing sector. It can be an IT. Any sectors should have a supply chain management. So what is the supply chain? What is a chain? A continuous a link between first process to second process and subsequent process. So that's we call as chain. And what is supply chain? The flow between these first sequential steps can be said as supply chain. So what is the supply chain management? So when you have these sequential steps, you need a process to ensure that these things goes smoothly and there is no deviation from what it is been written in the SOWs, that is called a statement of works, or in we call now in industry we call it as the business opportunities. In colleges we have like memorandums, many things. So in order to ensure this smooth flow of the processes or the deliveries from one step to next step, we must also have a management to look after these processes to ensure that these each step achieves its prioritized or it others to the set or stated work. So this management requires a lot of effort. Even let's say if an industry has starting from foundry, let's say starting from raw material to finished goods, industry has a lot of supply chains. Let's say raw material is procured from some vendor, so there must be a supply chain management implied to the vendor, to the company, the procured department in the company, let's say melting department. Because when a raw material is procured, when it comes to an industry, let's say example of foundry, it comes to the first department before melting. When then you put those raw materials into the melting, and parallelly to support the melting department, you must be having the pattern department where they will be having the patterns for all the molds. And parallelly the molds department should also be ready with the sand to make a cast. So once all these departments should have management people, and they must have a proper flow between them. So when a material is procured and and put into melting, then it passes to the molding. Then after the molding, it goes on to the knocking stage, and then it goes to cutting or cutting, gas cutting, many things like that. So after cutting, it goes us to salt blasting, something like the heat treatment processes are there, many subsequent processes to ensure that the desired material is freed from the existing mold. After that, then it goes into the machining department, where it has to achieve a lot of machining process like boring, slotting, various processes depending upon this one. Depending upon the SOPs, I think in a manufacturing sector it is called standard operating procedures. So based upon that, the appropriate objectives and appropriate level of metrics, the quality department has to work to achieve that. These things has to be met without any deviation, else it will lead to process non-compliance. So then comes the QA department. So these are the departments which has to collectively work together to ensure that a single product reaches to the packaging section. From the packaging, it has to get into the retailer, so or seller, and from seller it has to pass on to the consumer, and from consumer again the product may face failure. It like automobile brakes has some lifetimes. If you are going and buying a two-wheeler brakes, it doesn't have any warranty, but if you are going and buying a gearbox, it has some warranties and guarantees. So these things based upon this product after sales, we should have a department or a supply chain management process to ensure that continuous feedback is collected, so that case on, we call it as a case on a Japanese technique used to maintain a continuous improvement. And we again the feedback will be given to the particular industries management. There is a department for that, and they will collect the feedback. And if that is problem happens, like I think in 2006 or 4 the Toyota car had a very big very huge issue in its accelerator, which is caused by an a small chip having an issue. But the Toyota management was not able to figure it out, and they gave that analysis. Yeah.
So I think your slide is not moving, sir.
I'm not moving. I'm just explaining.
Okay, sir.
Okay, just hear me out. The slides, slides I've given to you, you can go through. I think most probably you won't be going through. Okay.
Yes, sir.
Yeah. Just hear me out. Then I'll move the slides. Okay. So these are the various things. Okay, these are the various things. Then NASA did the alliance, did the analysis, and they came back with a solution, and they gave it to the Toyota. Then Toyota recalled 1.5 million costs, and they fixed up the solution. Okay, so all this from from cooking or from making a product from the first phase of your industry till the last phase. You must have a management. So that is collectively called as supply chain management. So what happens is that if you look at these 4 words, you can see these 4 words. Okay. So like we say in our state, so like that, if anything happens within that 4 words, okay, that will not be realized or potentially known to other departments or other sectors. So many of the companies started to going beyond these 4 words. Most of the organizations have only paid attention to what was happening within their 4 words. Okay. So supply chain is active management activities to ensure that customer value is achieved and yet sustainable edge has been maintained. Okay. So as I told, supply chain, it's a network of organizations and business processes for to procure materials or to get the raw materials and to transform those raw materials into finished products. So that's a supply chain, and the supply chain management it means the integration of suppliers, distributors, vendors, and all this. For all this to be successful, they need a proper and a well committed logistic department to make this as a cohesive process, that to make them to come in as a single line, so that they will be on the same page. So that's the objective of the supply chain management and the supply chain management process. So here comes the all the latest technologies to achieve this supply chain management. So the IT department ensure that each and everybody has the update about the product, where what is the status of the project, the product. Let's say if it is whether the product is moved from initial stage to the next stage, first stage to second, or the subsequent stages. So there comes the our IT department and other process activities. Any questions here? Okay, I will take it as no. So these are some of the strategic processes we have to familiarize or which exist here. On the left side tells about what is meant by that and what is the objectives of those things. So first would be you have to any industry has to start with the planning. So once you have the planning, in the planning itself you must establish the policies or objectives or the main core value of the businesses that you want to achieve. And so the objectives, like you have to simplify your policies, because and the policies should be in such a way that there should not be any legal issues aftermath. So and apparently the policy should ensure and it should it should meet the requirements that all the departments are covered legally and ethically. So that where comes the network design. So in your when you prepare the policies, you should you should make in such a way that your policy has a very strong and build up network design. And this mapping, we call it as a mapping. You should have a very good mapping based upon for all the departments involved. Moving to the next tactical. So as you know, the tactical is like management. It's about managing the resources. Let's say an example, when it comes to managing resources in a manufacturing sector, it will be about raw materials, man, machine, manpower. There are money, so that is financial. So all these tactical resources should be properly planned, and it should be built in such a way that any forecast, any future future outcomes can be managed. That let's say yesterday's news, like our L&T chairman Subramanian told that he was telling that it is hard for them. He needs only 4.5 lakh. He needs 4 to 4.5 lakh employees. But the way that he hires people is almost like a triple or four times of what he has. The reason is that he's unable to mobilize the people from one place to other places. So this tactical approach should be very much effective. So even L&T is not able to achieve these tactical approaches. We know L&T is a very huge organization, but yet they face that is due to several hurdles, several parameters. We need to respect employees' version of their wishes also. So based upon these parameters, still there are many outcomes or very variables that we have to consider while planning this tactical approach. So this strategic approach, when you have a good financial team, or you have a very good financial background, you will be able to build this strategic. But when it comes to tactical phase, it is very demanding, and you need very talented management people to handle this tactical phase. This is the phase where Google, or if you look at Elon Musk, a couple of years ago he bought Twitter and immediately fired 80 to 82% of the employees. So now he has built, with Trump he has formed a DOGE, Department of Government Efficiency, and he is planning to fire several federal employees. This is because Elon Musk's tactical approach is very very straightforward. It is very demanding. So those are the things that has to be considered. So then comes the operation phase. This operation phase where we as engineers draw our line. we must make lot of plans, a lot of designs are required to make how the process has to be done, how the outcome has to be met, what happens if something goes wrong, what is the backup plan. All these things has to be planned in the operation phase. So execution is, I have mentioned only as a build and transport. Execution also has the packaging department where, it depends upon the product. If it's a software, we have to deliver it a software package. If it is an, manufacturing is a car, then you have to, deliver it as, as it is. Okay, if it is a Rolls-Royce car, then you have to, you must have a 16-wheel or 20-wheel truck. You must have a carton box that so much that 50 people can be sit inside that box. You can, you should deliver that, Rolls-Royce within that only. Rolls-Royce has its own delivering, packaging item. Okay, so likewise, the execution phase comes about the tells about the logistics. The logistics involved in all the phases. So that has to be that's one of the important point in SCM. Logistics plays a major role. Okay, moving on to the next slide. So as we told, so all our business goals, we build or we create the business goals to sell the product to the customer, and the customer should feel that our product or the product that customer buys should have a value that they must that the product should bring a satisfaction to them. Because if you understand that in a product, no matter how much advertisement you put, let's say for example, as college professors, you all go to various centers, various visit various cities to for admission for admission activities. You tell them that these are the activities that our college has done. The marketing that you project that your college in such a way that the marketing is such a fancy and a very alluring to pull the people. But there is a one behind concept is that oral, okay, by mouth of when a student recommends that this college has a very good thing, okay, so that oral communication or oral value brings the or makes the product successful. So we should have a feedback mechanism to fix the faults in our product. So the main feedback, the feedback can be nowadays, the social media is such a way that our feedback or feedback of any product can be known within a day. Let's say we recently had a film Kandua, right? So that once released in the theater, it was gone out. So these things has to be considered, and the next time when the production department, that film production department makes that such a films, they should consider this feedback. They should do the proper analysis, and they should ensure that this amount of money is being put, then these analysis to be done and proper things has to be made. So I don't think our film industry has any feedback mechanism, or they are not ready to do their analysis, because when you do an analysis, it will bring so many negative things to you. But our mindset is not ready to accept many negative things. So we should not think in that way. We should start thinking in broader way. Only then we'll be able to get the feedback that which will help you to value the customer. So once you start valuing the customer, then the feedback mechanism will help you to achieve a great deal of incompetence that your product has compared to the other product which is existing in the market. So the main objective is one of the main objective of SCM is that one. But this slide tells about what are the phases has SCM's objectives. There's a enterprise coordination of the manufacturing or industry and business processes. Then it should have an effective distribution system. Of course, without effective distributed system, we will not be able to move our a product from face to face. And this responsiveness and accountability to customers, this is a very area where a product owner should have a much concentration once the product is being released into the market. Okay, moving into the next slide. So when it comes to SCM, we just have the very simpler terms we should consider, not about these things, only about the manufacturer, that the product where it is manufactured, and then distributor, then it goes to the retailer, and then to the customer. So these four phases you have to consider. So each phases has upstream and downstream. If you take before manufacturer, okay, it has there are several departments where manufacturer alone will not have all the product or all the raw material that they need. They must have procured by someone, and they must have sell smaller. Let's say if they are manufacturing a bearing, a cap, if they are manufacturing an engine, then they won't be manufacturing all this product. They may give some subcontract. So this might have some upstreams and downstreams. Moving to the next slide. So supply chain activities, has a considerable amount of sources, that is resources, has to be needs to be spent. So when it comes to organizations, their ability to think about the SCM and IT, that is information systems or information technology, to support SCM in India is not that much scope for. People in India or industry owners in India, they are not ready to invest large amount of money into SCM's IT. But whereas if you take for example, let's say Germany. In Germany, even let's say we have Palamudar Nilayam, we have content department, like this. So like this, retailers are so many marts are there. If you take people or those retailers in Germany, they will invest some considerable good amount of money into the IT department of the retailing sectors. So similarly, their supply chain is also in such a great way that they invest more money to ensure that infrastructure is built very well, and all the phases, all the things that are happens in and around is. Guys, is the screen visible? Slide is moving or not?
So right now it's moving there.
Oh, okay. Sorry about that.
Okay.
Okay, if the screen is not moving, you immediately tell me.
Okay, sir.
Okay, let me stop presenting. Let me reshare. You can tell me in the middle, okay? Don't hesitate.
Okay, sir. Okay.
Because I'm at Bangalore, okay. Here, the coverage is good, but the problem is that I'm staying in Whitefield, where lakhs of people are there. So the communications, even we have good communications, it may go down. It's visible now?
Yes, sir. Visible, sir.
Okay, Professor.
Okay, okay. Okay. So coming to the infrastructure of the SCM is that it tells about the forward movements and backward movements. If you look at here, that's what forward and backward. They should be able to, let's say if a product is sent from first to second stage, then you open up the screen or you log into your website and see where your product is there. And let's say this can be a simplified, let's say courier service. So you can, or if you order something in Amazon, you get into the product, you look, you click on the delivery, you'll be able to see where where does the product, at what stage the product exists and when it will be delivered. So where the product is called forward mechanism, backward mechanism, and when it will be delivered is called forward mechanism. So these mechanisms will be ensured so that you will feel that the product will be delivered that is mentioned, that is just in time. So it meets the objective in the framed or set time. Okay, move to the next one. So there are, like you told, any business has its own setbacks, hurdles, or uncertainties. So when we are, in supply chain management, any one department facing, drawbacks or hurdles will cause the setback in the subsequent steps. So this uncertainty will cause, the next process to become late, and the other process again. It will go in a chain of, it will go like an avalanche. So that has to be, that planning has to be in such a way that you give an extra breathing time or buffer time to the process. Let's say if this particular process will be completed in 20 minutes, for the production people, you should give the 18 minutes time. If you give more time, they will take more, consume more time, your productivity will go down. But at the same time, when you are billing, you should give that it is not 20 minutes, maybe fix it as 21 minutes or 22 minutes. This is how, top level management functions. But it will not be known to the low level management. So, any late shipments or any production breakdowns will always, build into the, or lead to the supply chains. So this is called a bullwhip effect. So this bullwhip effect will cause, not a major, issues or major hurdles. Here we can call it as fluctuations. It will lead to some minor, even though some minor fluctuations could create a trouble for the distributors, because a distributor will be invested some amount for inventory. They, a distributor or a retailer will not, have the huge storage area where they will store everything. They must have rented it. They must have made some, for lease. They might have rented some places. If you don't deliver your product on time, just in time, if you don't other to just in time, then they have to pay extra. For if they are rented for 30 days, if your product doesn't come on the first day, if it comes on 10 days, then there, shipment is there that would get affected. So all this process will, will continually affect one another. So, and there is an this IT, infrastructure team will ensure that these products should be, made in time. If there is, if they are not made, they are not meeting their objective or their ensured policy on time, then the IT department will be in such a way that other department, subsequent department will be notified, or an alert should be triggered in such a way that they should be able to plan ahead and right. Okay, it's visible, right? Anyone? Yeah. So this is as I said previously. No, the information system that built in such a way that it should support the supply chain management to highlight where the product is, at what stage the product is, whether it will be reached or delivered on time. If not, then what is the steps has to be done. So these are processes or supports that IT brings into the SCM. So it decides what when and what to produce, where to store, and it helps in providing a very quick, rapidly communicate others. That is very quick response. If you get into the system, you immediately will know that where the product exists, at what stage it is there, or in what phase the product is there, and it will help you to track your orders, like status of the orders. Like previously we've seen that Amazon delivery or any courier deliveries, you'll be knowing where your order is. So, and as you know, inventory availability, then how to reduce the warehouse cost. My slide is visible, right? Guys?
Yes, sir. Yes, sir.
Session. Okay, just give me a second. Let me connect my laptop with the charger. Okay. I think this is slide number 9. You guys are seeing that? Anything left?
Yes, sir. Very good.
Yeah, okay. Okay, thank you.
Okay,
so
very.
Oh, okay, right. So this is the one of the few facilities that IT department brings into SCM. When you talk about IT department SCM, you could talk for 2 to 3 days. Okay, that's a vast topic. Each topic is a vast topic. Nowadays, I'll tell about this last slide. I have given some of the latest trends in SCM. We'll have some time spent over there. So all these processes tells about your supply chain planning system, execution system. Then what are the few currently what the technology is using. That in India, I think we have earlier here ERP, which I have not added here. ERP is getting outphased or outdated. Still, there are few companies which are using ERPs. So these are the softwares, supply chain management, currently uses. So moving to the next slide. So as we told, the same thing like previous. All these steps where initially I have mentioned only the flow of processes or flow of phases or flow of steps. Just give me a second, guys. Okay, yeah. So all these processes are interconnected. If it's a raw material, then it is connected. It has interconnection with the next phase. As a component, once component is made, then it has interconnect with the manufacturer. If it is successful, the manufacturer, that is a pack. The manufacturer could deliver a package as a retailer. If it is not successful, then the component has to be reworked, and again they have to go to the client, for getting whether any concession can be achieved with their product. If not, again, if there is no exceptions or received from the client that this product cannot be reworked, it has to be thrown into trash. So in that case, the product will be again come to raw material. So this is like this is the forward movement, and this is like a backward movement. Let's say if this is true, like algorithm in computer science, algorithms, simple algorithms that we study in the first semester or in the school days. like true or false. So this tells about the true, and this tells about the false. Okay, move to the next one. So these are the areas where SCM has to put its more concentration, or or it has to put their management people to achieve these areas. We have logistic, as I told earlier, logistic is the utmost important thing, because logistic will be employed into all the phases. So any movement between the places or phases or shop floors, so you need logistics between shop floors or between vendors and shop floors. Whatever kind of movement you need logistics. Then a proper supply chain strategy. Without the strategy, you won't even able to achieve the logistics. The strategy will has to be put into a well formulated supply chain planning, and the planning has to be in such a way that the application of the planning is makes it achievable, and in order to achieve that, you should have proper assets. For the assets, you should have a proper management. Assets not to measure tells about the machine or the shop floor or the industrial area. The safetiness has to be safetiness of the machine, safetiness of the people has to be considered here. Then comes the procurement department. Without procurement, we won't be doing any of these things. So procurement management has to be such an effective way that we should ensure, or we should have people, effective people, to buy the raw materials as cheap as possible. So, and then comes the product life cycle management. This is a very important phase. Compared to each phase has its own importance, but product life cycle, it's a very important thing that will give you a marketing will give you an edge in the market. It will make competitive compared to other products. Okay, moving on to the next slide. Initially, global supply chain has started using intranet. That is within the company. They used they used to have their own applications, or intranets, or they have websites which will be they themselves will be using to achieve that. Moving on to the next one. So nowadays we started using internet, but during this intranet and the web pages, these are the phases that was incorporated into that nets websites. So they might be having, from the starting, if you look at the planning and scheduling, that will be also available in the website. Then what are the suppliers that a particular product has? Let's say LG equipments in Coimbatore. So I have used I was part of one of the brotherhood of a LG company. So during my days, so they had an intranet there where there will be a planning and scheduling. And I think you guys will wonder, this planning and scheduling department, I think there's a planning and people, I think production planning paper, right? So we were using that book to create these things. I've seen people study that book to create these planning and scheduling things. So yes, that planning department has to be has to put their updates into the websites, and the suppliers, the details of the suppliers should be visible in the websites or the web pages. Similarly, procurement details should be available. Of course, logistic services or logistics solutions should be there. Then the production details should be there. At what phase our product is there. The production phase includes many parallel phases, and it will be a detailed web page. We were using Oracle intranets. LG were using brotherhood of that company are using Oracle's web pages. So then we should have a distributor or details about that in the web page also. Then inventory details, then retailers, shipping, then orders. And when it comes to customers, they might not have the exact details in your pages. This is about manufacturing sectors SEM. Here the customer means the distributor, so they will have distributors. Here you may wonder, already the distributors data is given here, but again this customer's data is about will come through distributors. The customer's data will come to retailer, that is a feedback, and again it will pass on to distributor and it will come here. So, and there are areas where companies take their own feedbacks, that also to be considered. But this was some 15-20 years ago. This is the process that they are following. Now a lot of things has changed. All this has become a concurrent engineering. We all know that concurrent engineering, that's a parallel engineering. Many technologies have flown in. Let's say there were waterfall technologies. Some 20-30 years ago they were following that one. Now we are using these agile technologies. You must have about agile. Now we are crossing that agile. So earlier I was talking about cloud, right? The cloud comes has left agile in sandbox, that agile itself is coming weak. Waterfall is an old one. Agile is becoming old now. And there are few new concepts are in the market now. So demand-driven supply chains. That's what actually push model and pull model. So you should have this, and the industry should have both these models to achieve the targeted value of their market value or market objective. I think in the push model, you'll have to ensure that all the things goes from one phase to other phases, and the pull model comes from the last to first. So that's one. Okay, so these are the some of the network designs that we have given. So like in the third or fourth slide we are seeing that network design. So this is a rough graph which is given shown to to understand that it's like nervous system within our body. It's like a neurological department. Our network should be in such a way that all these coverages has been met. Okay, I'll be moving on to the next one. Okay, so I think I'll start some of the questions based upon this one. I think you don't like questions, I understand. So I think this one is the last slide, so which will bring some happy to you. Okay. So the latest trending technologies in all the areas is applicable to supply chain too. So when it comes to AI, now AI is a very emerging trend. It's a catchy word. Every sector wants to invest in AI, but to be frank, there are only very handful of people in the industry who understand the AI very well. It's a very complicated thing. It involves patience, and it involves a lot of investment in resources for learning. It takes a company or organizations to study or to understand the failure in making the resources, their employees, to become a master in AI. They are investing so many amount of they are giving so many learning platforms like Coursera. There are plenty of the Udemy. So there are plenty of things available. They are investing, they are spending the money, but AI is a very vast field. It is a complicated one. The SEM is doing that. I think you might have students are might have watched YouTube videos. Recently, Amazon in US, one of the storage areas in their inventory, they fired 400 people and they replaced with robots. So this inventory management is completely, now it has replaced all the 400 resources, and it is completely run by robots. And these robots, it uses a lot of AI techniques, so that's one of the things that we should not be worried, but at the same time we should be have a mindset that in future most of our jobs will be replaced, that is inevitable, will be replaced by AI. But if you say no, in that perspective, if you start fearing that all of our jobs will be replaced by AI, no. Most of the jobs, not all the jobs can be replaced by AI, but you should have some advantage. If possible, you should start looking at the AI trends, because the students at other countries, or other various colleges, they are investing so much of AI, and they are also not they also don't understand that AI very well. Even we actually industry persons, when we are in industry, working in industry, we are also facing hurdles. We also sit for hours to understand a small concept in AI. It takes time to understand. I've been using some 5 to 10% of AI in my tool. I know it is causing so much havoc to me. It was causing so much confusions to me. I know we as a team will sit for hours to analyze what is happening. Let's say for one of the retailers is using a particular server. There will be no process running in that, but all of a sudden, the AI, that is, we call it as a Davis. We have a name for AI. We call it as a Davis. The Davis AI triggers an alert for the CPU if it crosses 95%, or it will trigger an alert when the particular page becomes valid timeout. So but when we get into the server, log into server, it won't reflect. Okay, but when after some time it really happens, it forecasts us that it's going to do that. So but this is what we thought it would do it, but what we are getting is not 100%. It is different. We are also working on that. We are using a lot of techniques to understand, but those are different scenarios are there. But I would suggest you as a students, you spend some time on AIs, which are AI is inevitable. You can't postpone that. Like in Terminator movie, right? Judgment Day is inevitable. Like that, the AI is always an inevitable. It's going to come. You should equip yourself with a complete knowledge in AI. And let's move to the blockchain. Blockchain, it is a decentralized ledger which helps you to understand or provide you the process and every steps in the process in a crystal clear way. That is a transparency. It makes or it provides the transparency, because when you have a system with so much of transparency, you will be able to trace it clearly. Okay, Indian political system or Indian like Superstar Rajini says that system has to be fixed. So this concept applies there. All the system, most of our system in India has no transparency. Nowadays it is becoming a little transparent, but many of the things are not transparent. If you don't have a transparency, you will not be able to trace it. When you will not be able to trace it, then there are the chances of all the unethical things to happen is high. So that's the main important concept. Blockchain, it will block you from going into unethical practices. So any unethical practices will cause a company. It will lead to a lot of disadvantages for a company. It will lose its profit. It will lose its value. So that's one of the main things that we should concentrate on blockchain. Blockchain, it's a very improving concept. You can spend it. If you see yesterday, Capgemini collaborated with one of the companies in UK. You'll be wondering what they collaborated. The reason may be funny, but this is happening. The UK, the rivers in UK are, not that much, it's getting started to get a little polluted. Not that much. Our values, our water level values are in worst condition, but they are in very good condition. Even in that very good condition, they want to maintain that. So they, Capgemini and other company has collaborated. They are developing a smart smart chips to ensure that where the pollution happens and how to arrest it. They started the R&D on that. So this, when they are beginning this one and their R&D, blockchain is an important concept they should employ, because that will that will give the transparency in the system. Let's say if you're going into the particular area of the river, and if someone, the area counselor, like say, so for example, okay, the area counselor or someone comes up and says no pollution, but there is a pollution, okay, and there is, they bribe and make it as a non-polluted area. So that will, their traceability goes off. Then they will start, ignoring the transparency, and they will bring the traceability to subtle. So all this will happen, and that's where unethical things starts to happen. So blockchain is one of the area that we must concentrate when you are building a SCM. Then, as you know, Internet of Things. So it's a very fast thing. I think, yeah, you as a students, you know much better on Internet of Things. Those are very important things. Very well will keep you in the market, and it will help you to achieve that you meet you meet required, or you have some adequate knowledge or adequate technologies with you to make the competitor go away. So IoT is a very important thing. And also, in order to achieve all these things, you need a faster communication. So I think 5G networks, we are in the 5G. I think Japanese has gone to 6G. So all these things are happening. Okay. With this, I'm completing my slide. Any question, guys? I think I've been speaking for more than 40 minutes, I guess, an hour. Okay. Sorry to make it as a boring one. You guys have any question? Okay, let me stop presenting. Hi, guys.
But if you have any doubt, you may ask.
ಎಲ್ಲ ಫ್ರೈಡೆ ಅನಿಕಿ ಫೆಬ್ರವರಿ 14 ತನಕ ಉಕಾರಷ್ಟುಮಾ okay guys, I think if you need if that's it, if no questions, I think Prabhu.
Okay sir, thank you sir.
Okay.
Thank you for your valuable speech towards us.
Okay, thank you guys, have a great day, happy weekend. Yeah, bye all.
Okay,
thank you.
So feedback link will be posted in chat box, so you can fill the feedback and you can leave.